Hello and welcome back to Maths with Mr. Duffield. I am the aforementioned Mr. Duffield, and I've had a lovely week off for my Easter holidays. I hope that you've had some time to relax as well. This is one of the Corbett 5-a-day worksheets that I've been assigning my LE, UF and GE. This is a higher level one, so probably more for the UF/GE groups. But I'm going to work through the whole thing because one of my pupils sent me their work, said that this one specifically had something that they weren't sure about in it. So I'm just going to work through the whole thing. This is the kind of thing that I'm expecting you to be doing every single day. The website has on the top here a date for a bunch of questions on it, and you should be doing one of these each day. It only takes a few minutes. Good, let's start. Y is inversely proportional to the cube of x. If y equals 4, x equals 2. Find y when x equals y. So x equals 1, excuse me. If y is inversely proportional, first of all, that involves y being inversely proportional to 1 over x instead of just fishy sine x. That's the proportion stuff that I've gone through with some of my sets already. And it isn't 1 over x, it's the cube of x. So it's 1 over x cubed. Remember our method? We replace the fishy sign with equals k. Okay, so that is the equation that we're effectively solving. If y equals 4, x equals 2. Substituting that in, y becomes 4, x becomes 2, and cubing that, 2 cubed is 8. So if I times both sides of this equation by 8, I end up with my constant of proportionality, my k. 8 times 4, 32. So effectively, the k in this equation is actually 32 over x cubed. And that is the relationship between x and y in this particular question. So find y when x equals 1. Replace 1 into this equation that I found and work out what y is. So y will equal 32 over 1 cubed, which is just 1. So, well, that's just 32. Question 1, done. Let's keep going. Question 2, what is the vector AB? If I'm going from this point to this point, but the only pieces of information that I have is this vector here, vector B, and this vector here, vector A, I have to use these steps that I have been provided with. So, to get from A to B, I've got to go this direction and this direction. Now that is minus b, because we're going in the opposite direction that vector b is given to me in, because we're going in this direction, not this one. And then we're going to go along the same direction as vector a, plus a. Cool, that's it. Question 2, done. Question 3, this is the one that my UF was struggling with. I think it's because the way that this is laid out is a bit confusing. It's it looks like a parallelogram and a tree here. Now the fact that there's a tree there makes me think, well, this is actually like a three-dimensional problem, okay, where this parallelogram is actually a square on the ground and this tree is like a height that's coming out of the floor. That means the distance AE is the hypotenuse of a three-dimensional right-angled triangle that's kind of sloping, if you will. Okay, now if I label this side 10 meters and this side 9 meters, you'll see more that it's meant to be a representation of a square. Yeah, they are all meant to be right angles, and it's just angled funnily because it's representing a 3D space. So how do I work out the height of this length, the length of this length, sorry, AE? Here, well, I need to know what this length is, which I can work out using these two side lengths and Pythagoras. 10 squared is 100, 9 squared is 81. That will make this length AC squared. 181 is AC squared. So I'm going to square root 181 to work out what the length AC is. You know, I can just leave that actually at the moment as a square root, because it doesn't make a particularly nice number. It's not a surd or anything. It can't be simplified. So that length here is the square root of 181. How do I work out the length AE? Well, again, I know that this is a right angled triangle here. It's root 81 squared plus 4 squared square rooted. Okay, so that's 181 plus 16 equals that length that we're looking for squared. 181 plus 16 is 197, and we're going to square root that 197 to make the length AE. So AE is root 197. It rounds to, well, about 14.04 if you want to go to the nearest centimetre. Okay. I hope that makes sense. That one's a bit tricky because you've got obviously a representation of a 3D problem. That's a bit weird. The next question, kind of tricky, these questions, aren't they? Simplify the top and bottom half of these fractions. Well, these are quadratics, guys. You're going to factorize the numerator, you're going to factorize the denominator. The denominator I can see factorizes straight away. It's the difference of two squares. X plus 6, x minus 6 gives me a clue as to what one of the factors at the top might be. And indeed, it factorizes to x plus 6 and then x plus 4. Plus 6 on numerator and denominator cancel, so I am therefore left with x plus 4 on the numerator and x minus 6 on the denominator. That's that. Mrs. Jenkins is making decorations for a wedding. She needs 19 root 5 meters of ribbon in total. Mrs. Jenkins has 40 meters of ribbon. Does she have enough? Now, let's use what we know about surd notation here. 19 is the square root of 361. And when it's next to root 5 like that, they are being multiplied. I can write that as the square root of 361 times 5, which is the square root of 1,805. Now 40 is the same as the square root of 1,600. Okay, 40 meters is root 1,600, and 19 root 5 meters is root 1,805. Well, which one's bigger? This one is. 19 root 5 is greater than 40. So because of that, no, she does not have enough ribbon. That's me having finished working through the 5 questions of this 5-a-day starter. On Corbett Maths, you can scroll to the bottom of the April section of the page that you get this worksheet from, and you'll find a PDF with the answers, and you can look through and see that the answers are as they are, and mark them. Please, I encourage you, do that yourself. Take a picture of your work with your phone and email me what you get. I hope that this has helped you, and I wish you all the best in all your future endeavours. Take care.